Alright, so first guys, we had 3 types of rocks, right? That's something I should have learned in middle school. Igneous, sedimentary, and metamorphic. You guys also should learn about the rock cycle. It's not a complex, it is not a complex cycle to understand. But what I want you guys to first tell me is I want you to look at the word igneous. And I want you to really just kind of look at the first piece right here. Where have you seen a word that has that similar beginning? Not bad, but no. Yeah. So what does that actual phrase igneous mean?
Igneous means they are formed by a cooling of
Well, that's what they are. Okay. But
That's
what were you
what
gonna say? Not so much the high pressure heat, but basically it's from fire, right? Think about the word ignite. What does ignite mean to do? It's like, hey, excuse me. So the word ignite means to actually basically set on fire, to start the fire. So when we look at igneous rocks, that term igneous basically is nothing more than from fire. So all of these rocks that you guys see there, the 1 through 5, every single one of those is formed by the cooling of either magma or lava. Well, what's the difference between magma and lava? And magma?
Is it lava like after it comes out of the water?
There you go. Okay, so all the big difference there is magma is in the ground, lava is on the top of the ground, right? That's it. That's the only difference. On the surface versus below the surface. So when we look at igneous rocks, basically 2 things are going to happen. You can cool 1 or 2 places. You either get to cool on top or underneath, right? Those are your 2 places to cool. And so therefore we call them either extrusive or intrusive. Now, take back what we learned from the based I think Monday. If I'm extrusive, what does that imply? Extrusive meaning what? Like the exterior. So we're on the outside, right? So extrusive igneous cools where?
Outside.
Outside. So they're cooling on the surface. Is it cooler on the surface or cooler in the underground? It's cooler on the surface. So therefore, am I going to cool a little faster on the surface or underneath? I'm going to cool a lot faster on the surface. Now, next question. What does that cooling rate have to do with mineral growth? That's what we learned on Monday. If I cool really fast, what happens to my minerals?
Small.
They're really small grains. So your extrusive igneous rocks tend to be very small grain. Okay? An example of this is what obsidian is. It's literally flash frozen lava. Cooled so quickly that the mineral grains absolutely were basically prevented from growing at all. Now, on the other hand, with intrusive, we have very large mineral grains. And therefore, that's because they have lots of time to grow in terms of the cooling process. There's lots of time for them to grow. So what I want you guys to do right now is I want you to look at your list of igneous. And I want you guys to make predictions on what you think. List them as extrusive or intrusive. That's what I'm asking you to do right now. Look through all 5, list them as extrusive or intrusive. Okay, so let's make a list here. So basically, you guys looking at your list of rocks, you have obsidian, granite, basalt, scoria, and rhyolite. Those are your 4 or 5 rocks that you have there for igneous. Obsidian. Extrusive or intrusive?
Extrusive.
Extrusive for obsidian. What else is extrusive?
Number 4.
The scoria. So that's the red one. Okay, it looks like the actual lava rocks you guys might use for landscaping. Okay, and what about, and there should be one more. Number 5, what's it called?
Rhyolite.
Rhyolite. Good. R-H-Y-O-L-L-I-T-E. Rhyolite.
That's just L-I.
Just, okay, I had a double L in there. All right. Guys, so we're having a lot of talking. So rhyolite. Again, we know that they're extrusive because they have very, very small mineral grains. You can't even see the grains reflecting off the surface. But now you have 2 that are actually intrusive. What are they?
Granite and basalt.
Granite and basalt. And again, that depends on which side of the great pond you're on. In America, we call that basalt. Around the other side of the world, they call it basalt. You can be British for the day. It's fine. But anyway, so those are your basics. That's it. We're looking at the mineral grains. Now, what's kind of an issue with granite? You guys take a close look at your granite piece and really look at it. Guys, you can actually, the reflection, that's what I'm talking about, where you guys can actually see the mineral grains. Those little pieces of the reflection, those are pieces of feldspar. You guys remember yesterday we looked at the different minerals? You had the big blocky pink mineral that was feldspar yesterday.
Yeah.
All the pink in granite is the feldspar mineral. But then you see these little black flakes in there, correct? The black flakes is the biotype. And so that's really kind of important for you guys to make that connection that the minerals come together and they actually form different rocks. That's how we get rocks. So minerals are formed from the different chemicals or different atoms. And then those minerals come together and they actually form rocks. And so that's what rocks are made out of. They're made out of different minerals pushed together. So that's how we get granite. Now, one thing that's kind of neat is if you guys look at basalt, it's very dark, very gray. Well, basalt's actually less dense than granite. Granite's a very, very hard type of rock. It's very weather resistant. And for that reason, that's why a lot of homes now are starting to move toward the granite countertops. They're very resistant to scratching, to breaking. The only thing you probably could do is probably overheat them. But even then, they kind of, if they're done right, you can actually, absorb that heat and expand it. And so it's kind of a nice way to actually accent your homes with the granite countertops. Oops, too far. All right, so we talked about this, right? You there? In the earth, we have your intrusive and cool down here. And then we have your extrusive rocks over here. That's most what you got to know right there. By the way, some other common forms of igneous rocks that you guys might have around your home would be geodes. How many of you guys have a geode sitting at home, whether it's small or large? Really? It's just like one of those.
Nope, I don't.
Yeah. And there's actually a lot of people that pick up geodes because they're really neat. And when you buy a geode, some of you guys already smashed it open or cut it open. Well, a lot of times they're just simple rocks that you might not even think anything about. They're just these ugly rocks laying on the ground. And then you actually never know what you're going to get. So you have to take it over to the saw, and they actually slice it in half. Sometimes you get an open cavity, like this one right here. That's kind of an open, we have the crystal space in there. Other times, in most cases, what you'll end up getting, and I'll pass these around. Remember I talked about ugly rocks? So look at the back sides here. That's exactly what they look like. Not different from any other rock. But when you slice them open, you get very different outcomes. And that's why geodes are kind of somewhat attractive to a lot of people who like to collect these types of things because they're very rare to find. Now, there are locations in Indiana where you can actually go, literally, and it's down toward the south, but you can actually go down by the roadside, and they have a lot of road cuts where a lot of the geodes are buried. So you can actually get off from the expressway, go climb up the hill, and actually take out geodes. So it's kind of neat. So a lot of stuff that's going on in front drum. So I'm going to pass these around for you guys to take a look at. Hey, thanks for joining us tonight.